All right, let's dive right in because today we're talking about a piece of technology that solves what sounds like a completely impossible problem. We are talking about Coriolis flow meters and how in the world they manage to weigh a liquid while it's still moving. Just think about that for a second. That's kind of like trying to weigh a river as it flows past you, right? You can't just slice out a section of pipe and plop it on a scale. So, how do you do it? Especially when getting the weight exactly right is absolutely critical. That's the puzzle we're going to unpack. Measuring the volume of something, how much space it takes up, that's pretty straightforward. But in a lot of high-stakes industries, like food production or pharmaceuticals, it's the mass you really care about. Why? Well, mass doesn't change when things get hot or cold, but volume sure does. For quality, for safety, and for money, knowing the precise mass is the only thing that matters. So how did they crack this code? Well, the answer is this incredibly clever, elegant application of physics called the Coriolis effect. It's a principle that lets you measure mass just by creating and then detecting a tiny, tiny twist. So, in simple terms, whenever you have something moving inside a system that's also moving, or in this case vibrating, a new force just kind of appears. That's the Coriolis force. It's the exact same effect that helps create hurricanes on Earth, but here it's been shrunk down and put to work inside a metal tube. Okay, so here's how it all comes together inside the meter. First, you've got these internal tubes that are vibrated back and forth, almost like a tuning fork humming. Then, as your liquid or gas flows through those wiggling tubes, its own mass, its inertia, starts to fight back against that motion. That resistance causes the tubes to physically twist just a little bit. And finally, super-sensitive sensors measure the exact amount of that twist. The best way to picture it, think about a garden hose. If you try to wiggle an empty hose, it's easy. But try wiggling one that's full of water, it resists you a whole lot more. Same idea. And this, right here, is the magic. That tiny little twist, engineers call it a phase shift, it isn't some random side effect. It's a direct physical measurement of the mass flowing through. More mass means more resistance, which means a bigger twist. It's that simple and that direct. So now that we've got our heads around how this genius thing works, let's talk about where you'd actually find one. Because this thing is a true, unseen workhorse in some of the most important industries all around us. In oil and gas, they're used for what's called custody transfer. That's the official point where millions of dollars of product changes hands. If you're off by even a tiny fraction, you're talking about huge amounts of money. In pharmaceuticals, getting a measurement wrong could literally risk someone's health. These meters make sure every batch of your favorite beer tastes exactly the same, and they're tough enough to handle the nastiest corrosive acids out there. Basically, anywhere that precision is everything, you'll find one of these. So just how accurate are we talking? Well, a typical Coriolis meter is accurate to within plus or minus 0.1%. That is an insane level of precision. It's why they're trusted when the financial stakes or the safety stakes are sky high. But here's the really cool part. Getting that one super accurate number is awesome, but the Coriolis meter is so much more than just a fancy scale. It's really more like an industrial multi-tool. So check this out. From one single device, you get 3 totally critical measurements all at once. You get the mass flow, obviously, but it also calculates the fluid's density and its temperature with incredible precision. In the world of engineering, that's a huge deal. It saves space, it saves money, and it makes the whole system a lot less complicated. Now, of course, no single piece of tech is perfect for every job out there. And for all its amazing power, the Coriolis meter does have some trade-offs. It's a high-performance, specialized piece of equipment. So on one hand, you get these incredible advantages like direct mass measurement and that unbelievable accuracy. But on the other hand, all that technology comes with a higher price tag up front. And because it relies on that delicate vibration, it can be sensitive to a lot of shaking from the outside if it's not installed just right. It's a premium tool for jobs where you absolutely have to have the best performance. But of course, engineers have found some brilliant ways to build these things for the absolute toughest jobs imaginable. Dealing with corrosive chemicals? No problem. They'll make the tubes out of super exotic metals like titanium. Working in a hazardous explosive area? They've got certified explosion-proof models. And for the food and pharma industries, they're built with perfectly polished steel that meets the strictest hygiene standards. So when you add it all up, the accuracy, the direct measurement, the versatility, it starts to become really clear why this technology is, without a doubt, the gold standard in its field. When it all boils down to it, it's this simple. When accuracy and reliability are completely non-negotiable, the Coriolis flow meter is the industry standard.
It gives you a direct, rock-solid measurement of mass that other technologies just can't compete with. And here's one last practical bonus that engineers absolutely love. See, a lot of other meters need a long, straight, uninterrupted piece of pipe before and after them to work correctly. Coriolis meters? They don't care. You can stick one right next to a pump or a bend or a valve, and it still gives you a perfect reading. In a crowded factory, that flexibility is a massive, massive advantage.
The Coriolis flowmeter really is the perfect example of this hidden, invisible technology that just makes our modern world work, making sure everything from our gas to our medicine is made safely and correctly. And it really makes you wonder, what other incredible, invisible technologies are out there, silently running our world right under our noses?